Hey there, and welcome. Today, we're jumping into one of the first, most important questions you should ask when you get a new data set. Is my data normal? Now, this isn't about your data being weird or anything. It's all about understanding its fundamental shape. Because, believe it or not, that shape dictates which statistical tools you can actually use. So, let's dive right in.
You can think of it like this. Before you can play a game, you gotta know the rules, right? Well, data analysis is no different. A lot of the most powerful, heavy-hitting statistical methods have one major rule that your data has to follow. And that's really the big question we're tackling today. Is your data playing by the rules? Okay, so first up, why does this even matter? Why do we care so much about the shape of our data? Well, it's kind of like the foundation of a house. Before you build anything on top of it, whether that's a sophisticated analysis or a cool predictive model, you have to be sure that foundation is solid. And that's exactly what we're doing here, checking the foundation.
And this table here really breaks it down. You've basically got two big families of statistical tests. On one side, you have parametric tests. These are the powerhouses, but they're picky. They demand that your data has that normal shape. On the other side are the non-parametric tests. They're way more flexible and can handle pretty much any data shape you throw at them. And we always want to use the most powerful tools if we can, which is why we have to check if our data makes the cut first.
So what is this normal shape we keep talking about? Oh, you've definitely seen it before. It's that classic, iconic bell curve. So what we're talking about here is the normal distribution. And really, all that means is that you have this beautiful, symmetrical pattern where most of your data points are all clustered right in the middle, at the very peak of that curve. And then they gracefully taper off on both sides in a mirror image. It's what we see all over in nature, from people's heights to exam scores. And check this out. Here's the really cool part about a perfect normal distribution. In this perfectly symmetrical world, the mean, that's your average, the median, which is the exact middle value, and the mode, the most common value, they all line up at the exact same spot, right there in the center. And that right there, that perfect lineup, that's the dead giveaway of a normal data set. Which brings us to a really handy rule of thumb. If you just calculate your data's mean and its median, and you see that those two numbers are pretty far apart from each other, well, that's a huge red flag. It's one of the quickest, simplest clues you can get that your data is skewed one way or the other and isn't following that nice, symmetrical bell shape.
All right, enough theory. How do you actually check your own data? Let's get practical. We're going to start with a couple of simple visual checks that can give you a really quick feel for your data's shape. There are really two main ways to go about this. The first is just visual inspection, basically eyeballing it. It's super intuitive, but yeah, it can be a little subjective. The second way is to run a formal statistical test, which gives you a hard, objective number. We're going to start with the first one, just using our eyes. Okay, so for our visual check, we've got two main tools in our toolbox, the histogram and something called a QQ plot. Let's talk about what you're looking for in each of these. The histogram is awesome because it's so straightforward. It's just a bar chart showing you how often different values pop up in your data. It's that simple. If your data is normally distributed, that histogram should look just like the bell curve we've been talking about. One big peak right in the middle and then two symmetrical slopes coming down on either side.
Now, the QQ plot can look a little intimidating, but trust me, the idea behind it is super simple. It basically plots your data points against where they should be if they were part of a perfect normal distribution. So if your data is normal, all those little points will form a nice straight diagonal line. If you see them starting to curve away from that line, like an S shape, that's a clear signal your data isn't quite playing by the normal rules.
Okay, so looking at plots is great for getting a gut feeling, right? But sometimes you need something more concrete, a more objective answer. That's where statistical tests come in. They take you beyond, it looks kind of normal, and give you a definitive number to work with. So we can look at a few key numbers. Skewness is basically a measure of lopsidedness. A value of 0 means it's perfectly symmetrical. Kurtosis is all about the peak and the tails. Is it super pointy or kind of flat compared to a normal curve? But for the final word, a lot of people turn to a formal test, and a really popular one is the Shapiro-Wilk test. The Shapiro-Wilk test is fantastic because it boils everything down to one simple number, a p-value. The best way to think about a p-value is like a surprise-o-meter. If you get a really small p-value, and the rule of thumb is usually less than 0.05, it means it would be super surprising to see data that looks like yours if it were truly normal. So we conclude it's probably not normal. A big p-value means no surprise, and we're good to go.
It's a really solid way to get a clear answer. So what happens if you do all this work, you run the tests, and your data is not normal? Is it game over? Do you have to throw out those powerful parametric tests? No, not at all. You've got options.
You've got two main paths forward. First, you can try to transform your data. This means applying some math to it, like taking the logarithm or the square root of every value. Sometimes, this can pull in those long tails and kind of nudge the data into a more normal shape. But if that doesn't work, or if it just doesn't make sense for your data, you can simply switch over to those non-parametric tests we talked about. They were built for this exact scenario.
You see, at the end of the day, checking for normality isn't just some boring statistical step you have to tick off a list. It's about respect for your data. It's about making sure you're using the right tools to truly hear the story it's trying to tell you. By understanding its shape, you make sure the conclusions you draw are the right ones. Your data has a story to tell. The only question left is, are you ready to listen properly?